Hello and welcome back to the channel Understanding.Concepts.Of.Physics, and here we are to understand today the rules of logarithms. As you can see on the screen, we have been doing logarithms since past two to three videos, and we have learned how to get the logarithm of a particular number, how to find out log for number which is greater than or equal to 1, and for number which is less than 1, and we have also understood how to find out the anti-logarithm of a particular number. In case you haven't watched those videos, I would suggest you, highly suggest you to go back to those three videos and then come back to the rules of logarithm. And very quickly in coming two videos, we are going to see how to use logarithm for calculations. So let's just quickly start with rules of logarithm, and I've just clubbed them. Again, I would like to add a disclaimer over here that we are studying logarithm for the calculation purpose, and we are not studying logarithm as a function. It's a mathematical concept, and a math teacher would be in a better position to explain logarithm as a function. But we are here to understand how to calculate using log. So the rules of logarithm says that if suppose you have two numbers, let's say a and b, and if they are multiplied to each other, and suppose if you want to find out the log of the product of these two numbers, then the property of log is that whenever there is a multiplication sign, you give log to both the terms. You distribute the log to both the terms, but you have to add a plus sign instead of a multiplication sign, because log is going to make your task easier. It's a tool to calculate. So multiplication will become easier, and addition is already easier compared to multiplication. So log a plus log b. So what you are supposed to do is you are supposed to find out the log a from the table and the characteristic, and you are supposed to find out the log b from the table as well and the characteristic, and then you need to add the add the numbers. Now here you would wonder how is this going to help with calculation. Just keep following. Maybe in 2-3 videos we are going to really calculate complex difficult calculations using this logarithm. So just remember, wherever there is a multiplication sign, you give log to both the terms and you put a plus sign. Now if multiplication takes plus, division will take a minus sign. So suppose if you have a log a and a log b, log a upon log b, then you can just put a minus sign and give log to both the terms. So you can subtract them, and then you have a process of finding out the anti-log, and rest of the process would be discussed in future videos. This is the second. So just remember, wherever there is a multiplication, you put a plus. Wherever there is a division, you put a minus. And the third rule is, let's say if I have log a to the power of b, like b is in the power of a, then the property of log says that this number you can multiply it ahead, and you can just keep on going to find out the log a. So it looks something like this. B comes ahead, the power of a comes ahead, and you write as log a. So this property, again, when we'll be using it for finding out powers and squares and roots, we'll be using this third rule for logarithm. Now just a disclaimer over here, okay, if suppose it is something like this, log a to the power 2. Now this number, this part which I have written in red, this is not like this property will not get applied to this kind of calculation, because this is the square of the log of a, and this property is applicable to log of a the whole square. Like if you are having only a square, only then this 2 can come ahead, not when it is entirely squared. So if this is squared, and if you write it like this, 2 log a, you are going wrong. This is wrong. So log a the whole square you can write as 2 log a. That is fine. This is correct. But if it is whole to the squared, you won't be able to bring this over here. Just keep that thing in mind. And the fourth is, okay, suppose if I have log a to the base b. Now what is this b? Now every log has its base, and normally when we talk about finding out log using a table, we use to the base 10, to the base of 10. So the table which I showed you in the previous two videos, let me check if I have it. Yeah, I have it. So this is an anti-log table and this is a log table. This two tables, if you also are having, it is to the base of 10. It is to the base of 10. But you can have bases of any value, like you can have log to the base of 2, you can have log to the base of 23, you can have log to the base of 2.718182. All these numbers are possible. You can have log of to the log of some number to the base of 2.718182 and so on and so forth. You can have to the base of 10 as well. Now whenever we write to the base 10, you can write 10, but in case if you do not write, it is implied that it is to the base of 10. And whenever you write log of n, like ln, like you are not writing log but you are writing ln. Now ln stands for natural logarithm. Natural logarithm. Now what is this natural log? Now natural log is basically its base is e. Now you wonder what this e is. Now e is an exponential constant. It's an exponential constant. So exponential constants ka value is 2.718182 and it keeps on going. It's an irrational number, but in mathematics it's seen like e is a number which continuously keeps repeating again and again. So that's why this number is given the value as e. Like how pi is. Pi has a value of 3.14. Now if you take any circle, any circumference of a circle, right, starting from this point, just a minute, I made a mistake. Okay, starting from this point to this point, okay, from one point to another point. Now if you divide the circumference, that is 2 pi r, and if you divide it by its diameter, you will always get this value of 3.14. So that's so special about this pi, 3.14. So 3.14 is basically a number when you divide a circumference. Like even if you measure it, like if you measure this something in value, like measure with some meter scale or something, and if you divide it by diameter, you will always get 3.14. That's so special about pi. Same way, exponential constant is one of them, which is very important in mathematics. So there are two kinds of log which is most commonly used. One is to the base 10 and the other is to the base e, where e is the exponential constant. And exponential constant, if to the base e is present, you sometimes write as ln, which implies natural log. When there is nothing written, normally we should be in noting that which base we are in. Now suppose if I have log a to the base of b, which is equal to, let's say, c. Log a to the base b, which is equal to c. Then I can say that if I wish to remove that log, then I can say that this b will go to the other side and b will take c in the power, and this a will remain alone without the log. So this is one of the properties of logarithms we'll be using in equations and articles like radioactivity and articles like simple harmonic motion. So there are times where you will be using this kind of equation. So to summarize, there are 4 rules of logarithms. I am not saying that there isn't any 4th rule. There might be 4th rule, but whatever is needed for calculation, I am just mentioning that part. So wherever there is a multiplication, you put a plus. Wherever there is a division, they put a minus. Wherever there is a power, you just remove that power and bring it to the front. And if suppose I have a base, if I have mentioned a base, then base can go to the right hand side, take everything on the right hand side to the power, and a will remain alone. And this is the way how we remove a log from a particular number. So we are basically removing a log from a particular equation. So from this equation I am removing that log. So in case if you are still with me, thank you so much for being here. I congratulate on you on your efforts to study. Thank you so much for watching. Subscribe the channel in case you haven't done so. Thank you so much. Bye.